Okay, you guys, we are now jumping into Module 26, which is the first module for Chapter 9, which is Water Resources and Water Use. So Module 26 basically is going to present to you the major sources of groundwater, to take a look at the largest sources of fresh surface water on our planet, and to lastly explain the effects of unusually high and low amounts of precipitation. You might recall from Chapter 4 that freshwater biomes, because that would be drinkable water, includes streams, rivers, lakes and ponds, and freshwater wetlands. You should also recall from Chapter 4 that climatic differences vary across the world per biome. So basically, rainfall is going to vary in different regions, and those are patterns, year-to-year patterns, which is what determines the climate of those areas. However, you should also remember that due to global warming, we are anticipating and are actually already seeing changes in those climatic patterns, and you should be interested in knowing how various communities and populations are being affected by those changes, including those populations of the natural world. So in other words, other than human beings. Groundwater is very important for human use, and in this diagram here you can see on the left we have basically the Earth's oceans taking up 97.22% of all water on the planet. So our oceans are comprised of the largest amount of water in general, but you should know, if you've ever been to the beach and you've ever gotten a big splash of salt water in your face and in your mouth, it's not something that we are supposed to drink. So take a look at this little slice here. From the entire 100% of water on our planet, only 2.78% is fresh water. That's not a lot. So take your attention now over to this pie chart here, and you can see how the fresh water breaks down. So of that 2.78%, which is a very small percentage, 77.28% of it is locked up in ice and in glaciers. The next largest amount of fresh water is found in below ground areas, which we're going to learn more about in this presentation. And then a very, very small slice of it is going to be found in the atmosphere, and that's what actually would comprise the precipitation that the planet can experience through various forms of weather and phenomena. And then only close to 0.5% is found in freshwater bodies. And so we're going to take a look at that too. So kind of from this diagram, I want you to think about these questions that I'm going to ask. What do you see as the primary repositories of fresh water on our planet? Where is it found? Which repository is the largest? Of all the water on our planet, how much of it accounts for fresh water? How much or what percentage of fresh water is surface water? And then what percentage of water is accessible for human use? So, do we get water from glaciers? Not really. Do we get water from below ground water? or do we extract it from freshwater bodies? So some questions for you to ponder. Basically, less than 1% of all water on the planet is accessible for use by humans. So that is an extremely small amount of fresh water that is available to billions of people. Groundwater. So groundwater, water which is found beneath the ground, can be found in aquifers, and there's two types of aquifers. There is an unconfined aquifer and there's a confined aquifer. And so aquifers, you're going to see a picture of one here shortly, but basically the aquifer is a permeable layer of rock and sediment that contains groundwater. So it's going to be kind of like an underground cavern of sorts. But one that is closer to the surface, those are typically considered unconfined aquifers because they actually have porous rock that meets the surface. So unconfined aquifers are usually recharged regularly by precipitation through weather-related events. A confined aquifer is typically found even lower in the ground, and it is surrounded by impermeable rock. So that's where we're looking at like bedrock, and we're looking at granite, or we're looking at really, really thick, dense clay where there isn't a large amount of water coming from the surface trickling down into the aquifer. It's actually blocked by an impermeable rock layer. So while both of these aquifers are very, very important, you should understand that the unconfined actually gets recharged more frequently, where the confined aquifer takes many, many, many years to replenish itself. Here's a visual for both of these aquifers. So basically your house, right? This is the surface area. And then below the surface, you're going to have your horizons of various types of soil, which you guys are aware of from the last module. And then beneath that, you're going to have this cavern of water, and this is the unconfined aquifer. And remember, this one recharges pretty well, yearly with normal occurring climatic patterns. The water is going to hit the surface of the planet, and then it's going to trickle on down through more porous and permeable soil layers, and it's going to end up in this unconfined aquifer. Notice there can be another layer of very dense land, and this is considered an impermeable layer, which means water does not pass from above through this area. Okay, it's going to actually receive its recharging or replenishing from another location. Perhaps it's a singularity or singular spot at the surface that's going to charge this confined aquifer. But you really need to remember that these confined aquifers take much, much longer to get replenished because of the impermeable rock layer that it's kind of sandwiched in between. A point worth mentioning here are the types of wells. So here we have an artesian well. This would be a man-made well. And these people have paid for the artesian well to be drilled basically down through the unconfined aquifer, through the impermeable layer, and into the confined aquifer. And most likely this would be people that would be trying to water, large areas of agricultural land, making sure that they have, a sufficient amount of water supply for that particular demand. Over here, we have a smaller well that has been basically drilled through just this surface layer of soil. And basically, these wells here tend to, they can dry up. If this water table drops low enough, let's say it's a drought season, or let's say that these people are using way too much water, they can actually decrease this water table here so that it actually falls below the bottom of the well, and they can actually run out of water through this particular well, With the confined aquifers and the artesian wells, those go much, much, much deeper into the depths of the earth. And so these are typically much more fluid flowing. But remember, once we've tapped into this layer, we're dealing with replenishment that takes thousands and thousands of years to replenish. More on groundwater, you've got your water table, which is the uppermost level at which the water in a given area will fully saturate the rock or soil. Groundwater recharge is where water can percolate through the soil and make its way into an aquifer. A spring is a natural source of water formed when it gets to the ground level or the ground surface. The water can actually percolate due to natural pressure of the land on the water, and it can actually push it up and out of the spring. My husband, who is a rancher, is very good at creating spring boxes, which are found around naturally occurring springs. And then they tap a tube, a plastic line or tube into that spring. And that's actually how he fills up the troughs for his cattle to drink from. The last one here is an artesian well, and this is a well that's created by drilling a hole. Remember, this is going to be a hole that's been drilled into a confined aquifer. So the artesian wells go deep, deep, deep within the planet. All right, this is in the Midwest. This is the Ogallala Aquifer. It's also known as the High Plains Aquifer. It is the largest in the United States, and you can see here that this aquifer, which is below ground, it actually rests underneath North Dakota, Nebraska, Kansas, dips over here into Colorado, Oklahoma, and North Texas and eastern New Mexico. Okay, and then you can see the color variations are going to share what amount of water is actually extracted in those areas. So who's using most of the Ogallala Aquifer and why? Which states? Why? It's actually a sad case. This is an aquifer that has reduced itself by more than 16 feet now, and it's because these regions are high agricultural areas. So North Texans and those that live in southwestern Kansas, they're using it for agricultural purposes to feed who? Not them. To feed the world, actually. So this area here is also Tornado Alley, but it's also considered the breadbasket of our country, and we raise most of our wheat and other agricultural products in this region. It's the greatest area of agricultural output, and we actually send a lot of this food outside of our country to feed other nations as well. So this is known as the breadbasket, and that's why that Ogallala Aquifer is tapped into so frequently. So another look at groundwater. Here you have a couple of concepts you need to be aware of, and one is a cone of depression. And if you look at this diagram up here in the upper right-hand corner, you can see how it's an upside-down cone, or not an upside-down cone. I guess that's a right-side-up cone. But anyway, as these people use this well, and they're sucking up the water through like a straw, okay, you're going to see this cone of depression occur if it's being extracted too quickly. Down here we have saltwater intrusion, so this would pertain to areas that are next to a saltwater area or ocean. And so let me take you to this next slide. There's more on the cone of depression if you need it, but I wanted to show you this one here. So here's the ocean on this side for saltwater intrusion. You have fresh water that would be found underneath the surface of the continental land, okay? But if we extract fresh water quickly and frequently out of this freshwater zone, you can see how the salt water will push its way inland. And so that can be unhealthy, especially if these people are watering or irrigating agricultural land meant for plant